everybody. So I've got a couple of common slot power supplies, a prototype for a controller, and this LCD screen that interfaces with this and talks to these. So this whole thing got its start back in Bitcoin mining days when I fooled around with Bitcoins over 10 years ago. And I had something like this for to control the miners. And that had 4 of these supplies, or 4 common slot supplies. The board, of course, had 4 slots. And these were, I knew somebody who did stuff with metal, and they made me a cage for these, so these could be hot plugged. So, like, they would sit in the server, where you would simply, you know, grab them and grab the lever and pull the power supply out. It supported all the hot plug and everything like that. And this still does. This derivative of that does support the hot plug. So I can pull a supply and add a new one, and the system will keep running. You know, so it's basically full high availability. But, you know, that was for Bitcoin. This is for radio stuff. So the way I did that originally was to look at the data bus when I added or removed modules from a server and just look to see what it would do. So, you know, fast forward a decade, I obviously don't have a server to do that with, and I don't have a DC load, access to a DC load. I did at the time. I don't have access to a DC load to figure out, you know, how much, you know, the system could sustain, see how efficient the system is. All I have is this backplane with these 2 red cubes on it, and, you know, these bolts, the M8 bolts. And I've pulled about 100 amps through the system, maybe a little bit more than 100 amps, and it's fine. It works fine with these 2 supplies. So that said, the thought was that as rudimentary as this is, maybe I would open it up, let other people dabble with it if they want, just see what the general consensus is on something like this. And if there's no interest, then I'll just you know, keep at it for my own use, which right now I only really need about 100 amps, so, you know, it's good for me. But in theory, the system could be expanded like it was for the miners, where it's not 2 slots, but 4 slots. And, you know, maintaining the hot plug and everything like that. So that's kind of the thought. I mean, just curious. You know, I know people have been fooling with these for maybe a year or 2. I didn't particularly find them that interesting for radio even 10 years ago. But you know, like I said, I need a bunch of current for something I'm fooling with. So I figured I would fool around with it again. So here I am, and I've sort of accomplished that. Only thing that gets displayed on the screen is basic information at the moment, whether or not a supply is slotted and to turn that supply on or off. Current bugs that need to be worked out is like fan control. Fan control just seems to be non-existent on these units. If a supply loses power, it'll ramp the fans, even with presence detection. So basically, if the supply is present in the system, but it loses AC, it ramps the fan. I don't remember that being part of the original scheme, but all of the supplies I have here do it. I'm not sure why, but it is what it is. I need to go through my notes and, you know, re-implement the protocol the best I can from my original notes. I know that since then some other people I've seen it where they've pulled the firmware off of these modules and disassembled portions of it, and maybe I'll look at that disassembly and you know, work out if they figured out you some of the things that I did not figure out or I didn't care to, because there were commands coming across the bus into these supplies that I didn't particularly care to implement. Because all I was really interested in is what's the speed of the fans? Can I change the speed of the fans? What's the current in, current out, temperature in, temperature out, which was all parameters that I could see coming across the bus. Voltages and so on and so forth. That's all I was really interested in. The stuff that I could do the power calculations for, like cost benefit analysis, which the original board would log and squirt out of Ethernet. Because I had the other board for the miners, different micro, had Ethernet on it. I could connect it to the network and I could get the data off of it. So again, this is an initial whack at this. This time I've got a different HMI. This place is an XTN display. I think the other ones were 4D, Australian 4D systems HMIs. So that's basically it. There really isn't anything else to say other than if anyone's a metal worker and wants to put something out there and help out, that would be cool. My original implementation for the Bitcoin stuff, I had I knew somebody who worked with metal. I was able to send them some supplies and fabricate a cage for the supplies that had the lock, the notches in the metal for the lock, that the supplies could be slid in, they could be locked in place, that supported the removal and the addition of up to 4 supplies. And the board, of course, mounted to the cage. And then the cage went into a larger cabinet that had screen on it and the outputs for all of the miners. So that might be an interesting implementation. If anybody is willing to, discuss, or, we could open this up and see how it goes. And that what brings me to the last topic of controversy with these. Well, at least I don't, there may or may not be. I know it depends on who you ask. I know people disable safety features on these supplies. I'm not sure how that's going to work with a system that has control where those things can be controlled. I've never modified any of these supplies. I never had any need to modify them. They're 12-volt power supplies. They're rated for 12 volt. Well, I mean, they're switchers, so their rating is their wattage. So, this is a 1.2 kilowatt supply, which of course at 12 volts is 100 amps. That is like its max rating. I don't recall the servers that these went into ever requiring such a current. That is their labeled current. And knowing power supply design, having done it, what the label says and what reality is are two different things. There's always a margin. So can they deliver more than 1200, 1.2 kilowatts? They probably can't. But whatever that margin is, we don't know. It's not like they wrote the margin on here. All I would say is that when you're modifying something like this to disable safety features, is you have to be really careful. Over voltage and over current protection are fairly critical on a supply when you're dealing with this much power, particularly when you start stacking more of them in a cabinet. The amount of power is a lot of power. So the only thing I would say is be safe and be sensible. One power supply per 15 amp circuit at 110 volts, you're fine. You put 2, you're not going to do it. Not a full load. If you're only drawing 50 amps or 25 amps a piece off of these, it's probably fine. If you're going to try to draw 200 amps off of these things, first of all, they're not rated for 100 amps at 120 volts. You have to derate. And if you change the voltage, you have to derate more. So, that's kind of the whole thing. And I don't know how to really build something like that into the controller. It's certainly possible because it's just maths. I mean, what's the voltage? What's the current? Let's, add some margin for derating and input voltage and all that kind of good stuff. And then you could come up with a safe load per unit. But anyway, just see what people think. If you guys want to see something like this happen, anybody who's into metalwork, maybe wants to make a cage and wants to contribute it to the community, I can certainly contribute the board designs and code and stuff, and maybe we can make a really cool, high availability and very safe high current power supply. Anyway, cheers for now. Catch you next time.